Good morning, dear students. In this lecture, we are studying about the geotechnical engineering and particularly geotechnical engineering based on the soil mechanics. Soil mechanics, so first of all, you have to know about the soil. What is the soil? So basically, soil is the decomposed part of rock. In other words, the soil is directly found from the disintegration of the rocks. And basically, soil contains two parts. First is rock, and second is organic matter or inorganic matter. In inorganic matter, these all the matters that not including any organic compound like decay of the animals, decay of the vegetation, decay of the trees, like that. The soil formation is basically done by batherings. And bathering, what is the bathering? Bathering is a phenomena of disintegration of the particles or rocks. So basically, bathering is are two types. First is physical bathering, and second is chemical bathering. In physical bathering, the basically physical bathering done by erosion of rock by wind, water, glacier, alternate freezing and thawing process. Basically, these processes are what? When wind blow at a high velocity, the wind also transports some particles of one place to another place, and when a river is flowing, then river also have transport some sediments, and when any environment, some condition are there, freezing and defreezing, or freezing on thawing condition. In that condition, the rocks are shrinkage and expand. So due to this phenomena, the rocks are converted into soils. So basically, the physical weathering rocks, after that, the soil that found by physical weathering, the soil properties are same as that the retained mineral positions. The apparent rocks and the new transported rock have same properties. For example, these soils are sand and gravel, and other we can say that the all the coarser particles, coarser soil like sand and gravel, these are formed by the physical weathering. In chemical weathering, the soil is formed by the chemical actions like acids, alkalis in water, air glacier, acid rains. In that case, the chemicals are react with the rocks and disintegrate it. That is called chemical weathering. In the chemical weathering, the soil have different composition and mineral properties like parent rock. Because of the chemicals are react with the rocks and convert into a different type of rocks and different properties of that soil particularly. For example, clay particles are the chemical weathered rock. The clay formation is done by the chemical weathering. According to weathering or formations, we are classified soil in different types. First up, we are discuss about the residual soil. What is the residual? Residual means that soil that located at location of formation, where soil are formed in particular location, the parent soil, the parent rock converted into the residual soil. All the properties of the residual soil with same of that the parent rock. Second one is transported soil. When soil is transported one place to another place, when soil is transported one place to another place, then the various transporting agencies are in picture. So according to transporting agency, the soil are divided in various types. Like first of all, we discuss about the alluvial deposits. Yeah, alluvial soil. So when a river transport a soil one place to other place, and a area there these deposits are deposit when these particles are deposited at a particular place. That soil is called alluvial soil. If transporting agencies change by river to lake, that soil is called lacustrine soil. So any lake bed that soil was found, that is lacustrine, and any soil deposited by seawater, that is marine deposit. Okay. Next one we discuss about the eoline deposits. Eoline deposit that here the physical or weathering, here the physical agency that transport the soil from one vertical place to one particular place to other, that is wind. And for example, the eoline deposit, the soil is loess. If the transporting agency is changed to glacial, or whenever the glacier are melted, that case the water flow with some sediments and deposit at a lower bed of area or a trench. There the soil is deposited. That is called drift or till. And next one is collovial deposit. Collovial deposit by the gravity effect. If any hill has a steep slope, if there is this steep slope, the soil or rock that are uh, fall because of gravity action. Because of gravity action, so that soil is called colloidal deposit. For example, talus soil is also there. Some special types of soil is also there. We discuss one by one. First is bentonite clay. First is bentonite clay. In bentonite clay, there is a very high percentage of montmorillonite. Actually, montmorillonite is a mineral, and the property of the montmorillonite is that whenever we added some water in that type soil, in which montmorillonite minerals is found, when we added some water in the soil have very swelling properties. Swelling properties. In case we are discuss about that. Ki whenever we added the water in the soil is swell about 2 to 3 times of the initial volume. And when the soil is dried, then soil is shrink. This montmorillonite minerals have the very play a very important role in that type of soil, and this soil is basically found by the volcanic ash or drilling muds. Second is black cotton soil. Black cotton soil. What is black cotton soil? Basically, the name according to their qualities. In black cotton soil, basically, same minerals is found in high percent. Same mineral is found in high percentage montmorillonite, and same properties are also there, which is high swelling and shrinkage potential. Whenever you add the water in the soil, that soil is expanded, and when that we are drying the soil is basically shrinkage. The variation in the volume changes is very high in that type of soils. So basically, black cotton soil is that soil who have two tendency to have swell and shrink, and the basic bearing capacity of that soil, black cotton soil, is very less. But that soil is formed by the chemical weathering of the basalt rocks. Basalt is a igneous rock. Uh, you know that whenever the hot molten magma is coming in the earth's surface and cooling down, that basalt rocks are formed. Next is loam. Basically, loam is the mixture of sand, silt, and clay. Basically, we are studying in geotechnical engineering various type of soils, and according to particle size, these are different names like clay, silt, sand, gravels. So basically, loam is the mixture of sand, silt, and clay, and also we are called at garden soil. Basically, three जो main features and sand, silt, clay is also found is there, and that soil combined name of that soil is called loam. And next one is the indurated clay. Indurated clay. What is the indurated clay? Whenever a clay is deformed at any place, found that at any place, when the clay is subjected with a very high temperature or very high pressure, then that the clay is converted into the indurated clay. This is the, on any and like that we are study about in the rock the metamorphic action. So the same metamorphic action will be there in the clay. So that soil is converted into indurated clay. Next one is organic clay. What is organic clay? When soil get mixed to decompose vegetation or dead and decay matters. We also study about the organic matter. What is the organic matter? Organic matter is what is the organic matter? Decomposed vegetation and dead decay matters are called is organic matter. Whenever the organic matter is mixed with the rocks, that soil is particularly known as the organic clay. Some special type of soil is also there. Muck. What is the muck? Muck is the inorganic and organic matter whenever it will be found in combined form. That soil is called muck. Peat. What is the peat? Peat. The fully decomposed organic matter. Fully decomposed organic matter like whenever a earthquake or a volcano is there, that the some most of the area trees are is decay at that particular place, and after many years ago Their places if coal is found, and that type of soil is also called peat. Next one is we discuss about the humus. What is the humus? The humus is a topsoil. It contains partially decomposed material. Whenever you say, if you are belongs from the rural background, the when we are deposited the some cow dungs at a particular place, that the upper layer of that particular place, that is contain some decomposed organic material. That rock is also called humus. These are the basic terms and basic types of soil fundamentals. Many times there is a objective and one marks question is there about the what is the soil properties. He give any example like that. Tell us what is the talus, and so he also asked about the also was the transporting agency, which type of soil is transported by wind, which type of soil is transported by glacial, like that some examples are there, so that a one mark question will be found at first. The best very important topic of the soil mechanics, that is the soil water relationship. Here we study about the soil water relationship. The basically soil water relationship chapter basically depends on the phase system. It is basically depends upon the phase system. So what is the phase system? Actually we are found any soil. That soil contains basically three components. The soil contains basically three components. First is solid particles, second one is water, and third one is air. So any soil lump is there. If I consider a soil lump is here, then it contains all three particles, some solid particles. These solid particles are different size, different shape, different and textures. These are solid particles, and between the solid particles we have found that some spaces we have voids. We have found some voids are also there. So these voids like that, these voids are filled by water or air. These voids filled by air and water. And this depends upon the type of soil. Like that, if a soil is contains in a dry condition, whenever a soil in a dry condition, that means the soil contains only airs. When soil is contained only airs, yeah, all, then we call that soil is dry soil. So if you pick any soil, that three particles are three systems, air, water, and solid are there. If we are open that soil, then whole the water is evaporate and the all voids filled by the air. Whenever you pour the water in a soil, the all air voids replaced by a water. That soil is called saturated soil. Saturated soil, we know that the soil is fully saturated if no air voids are there. So firstly we discuss about the three phase system. In three phase system all three components are there. Some air are there, some water are there, and some solid particles also are there. In case of fully saturated soil, all the air voids replaced by the water. In case of dry soil, the open soil, all the water is replaced by the air. All the water is evaporated, and the remaining place and the remaining the void space, the air is filled and air is filled. So first of all, the basically study purpose, we are considered at the three different zones. Basically, the soil is found in a combined form. We we can't separate these air, water, and solid in a different phase. But for to make easy study, we can convert it to three phase. Okay. So firstly, all three phase are there: air, water, and solid. But in case of we are have a special case like that, fully saturated, then three phase system is converted into two phase, because air is replaced by water. And second condition is that if the water is expelled or evaporate, then also three phase system into convert into two phase system. So according to there is volume relation and weight relationship, we consider that parts in a different zone. We consider air, water, and solid is three phase system. Diagram is here. So firstly, we represent left side में the weight quantity and right side volume of these phases. So firstly, we consider the solid, and the solid weight is ws, represented by ws, and also volume is represented by vs. The solid volume is represented by vs, and solid weight is represented by ws. Next is water. The water volume is represented by vw, and weight is represented by w, ww. Now here, air weight is represented by WA, and volume of air is represented by VA. We also know that the in the solid particles, and particularly in case of soil, the here is some soil particles. Here are some soil particles, and between them some voids are there. Between them some voids are there. The all the voids that are filled by air or water, that's it consider voids, that is consider voids. So if I represent the total weight of volume of air in total weight of sorry total volume of air and total volume of water in a combined form, that is called volume of voids. And the total weight of soil is capital W, total weight is capital W, and total volume is capital V. We also know that in as compared to solid or water, the air weight is very negligible. And the air weight is very negligible. In that case, we are consider the weight of air equals to zero. Weight of air is considered as zero, because as compared to water or as compared to solid, the air weight is very negligible in that case. So these this representation you have to memorize, and you have to make it a permanent memory, like volume of air. I whenever I talk about the volume of air, so you have to in mind I am talking about the va, and whenever I told about the volume of water, then your mind it is permanent set that I am talking about the volume of water is VW, volume of solid is VS, weight of solid WS, weight of water WW, weight of air is neglected here. So total weight is considered as a weight of water plus weight of solid. Now, now we are discuss about some relationship between soil water relationship. Like that, some terms are here. The mainly the numerical questions are because of from the this objective point of view. We studied some relationship like that. First term that are very important, void ratio. Firstly, if we discuss about the term void ratio, the representation of void ratio is small e. What is the void ratio? It is the ratio volume of solid. Sorry, it is the ratio volume of voids to the volume of solids. Here we write volume of voids, that means VV upon the VS. Okay. So what is the E? What is E? E is VV upon VS. Volume of voids upon volume of solid. Whenever we discuss about the volume of voids means the volume of air plus volume of water. These two terms are combinedly called voids. Okay, and then the void is volume of voids upon volume of solid. So we can also write it here VA plus VW upon my VS. It is a fundamental relation between the porosity and void ratio. We discuss about and that formula is also. The second term is porosity. What's the porosity? Porosity means, what is the porosity? Porosity means the percentage, approximately percentage of voids in the total volume. When we about when we talk about the total soil, when we talk about the total soil volume, that is capital V. Here capital V equals to volume of whole soil, that is also represent VA plus VW plus VS. Whole volumes, volume of air, volume of void, sorry, volume of water, and volume of solid is also there. And VA and VW we represent like VV, that is volume of voids. So here the relation is, what is the ratio? Sorry, porosity. Porosity. What is the porosity? It is the ratio volume of voids to the total volume. The basically difference in between the void ratio and porosity. The denominator here is volume of solid, or here volume of soil. Here volume of solid particles only. और here volume is of soil particularly. ठीक है, तो here these are the relation between porosity or void ratio. If you have porosity and then you find void ratio, then E is equals to n upon 1 minus n. Or if you have void ratio and you have to find porosity, then you can write E upon 1 plus E. That is the mathematical relation in between them. Now, third term is degree of saturation. What is the degree of saturation? Basically, uh, we know that the soil have three phases because we know the soil have three phases. First phase is solid, second phase is water, and third phase is air. Third phase is air. So basically, degree of saturation represent about the voids. Its term is related to the voids. How much quantity of water is there in total voids? How much quantity of water in total voids? So basically, the mathematically we represent degree of saturation is the ratio of volume of water to volume of voids. And that represent that how much water in particularly all voids. If saturation level is 100%, that means the voids filled by the water. if we if I told you that saturation level is zero, so what does that mean? Actually that mean is here the in voids the water is zero. That means the soil is dry. Okay, so what is the degree of saturation? The volume of water in a soil, the volume of water in a soil vary from zero, zero when soil is dry, and the volume of voids. This can be as a degree of saturation. So simply you have to remember that if I told about the degree of saturation, that means the what is the percentage of water in voids only. And the mathematical representation degree of saturation, it is the ratio of volume of water to volume of voids. Now next term is air content. What is the air content? Like that degree of saturation, we in a previous slide we study about the degree of saturation. Degree of saturation means that how much quantity of water in voids, and air content means what is the amount in voids above of air. Air. Just replace the volume of water by volume of air, and you can replace degree of saturation by air content. So if VV is the volume of voids, and that is volume of air plus volume of water. These two terms are there. So first we discuss about the degree of saturation. Degree of saturation is the volume of water upon volume of voids. Second term we discuss air content. Air content is what is it is the ratio of volume of air to the volume of voids. If I add these terms, S plus AC, S where S is degree of saturation, AC air content. So I can write it here VA plus VB plus VW upon my VB. I can write it here because uh, degree of saturation is degree of saturation is volume of water upon volume of voids, and air content is volume of air upon volume of voids. So here VB is common, then I can write it VA plus VW upon my VB. VB is also VA plus V, so I can directly write it here S plus AC to 1. So basically the relation between the air content and degree saturation is the summation of air content and degree of saturation always 1. If here air content is large, that means the degree of saturation is less. If degree of saturation is large, then air content is less. So in case of AD, in case of dry soil, the air is 100% because all the water is replaced by the air. In case of fully saturated soil, all air is replaced by the water. Now next term is percentage air voids. Here we discuss about percentage air voids. The percentage air voids is the ratio of volume of air to total volume of the soil. In case of air content, we consider only the volume of voids. In case of percentage air voids, we consider the total volume. Okay, the relation between the air content and percentage air voids is N equals to AC. Sorry, Na air percentage air words equals to the porosity into AC. AC क्या है? What is AC? Volume of air to volume of voids. What is the N? N is volume of voids upon total volume. And AC, what is the air content? VA upon VV. So here VV is cancelled out and the formula is from VA by VB. So we can write it here. Na equals to N into AC, where N is percentage air words, N is the porosity, and AC is the air content. Next important term is water content. Water content. Uh, in last previous slide, we study about the degree of saturation. Degree of saturation means the particularly water present in the void's volume with respect to the total voids. Here we discuss about the water content. What is the water content? The water content is the ratio of mass of water present into the mass of solid particle is called water content. These above five terms relation between the volume terms, between the volumes. These five terms like that: void ratio, porosity, air content, degree of saturation, percentage air was related to the volume. Here we consider the weight. In case of water content, we consider the weight. So what is the water content? Water content is the mass of water present in the soil to the mass of weight, mass of solids. Okay. So what is the water content? Weight of water upon weight of solid. The limit is between 0 in case of dry soil. You also know that if the water content is 0, that means the soil is dry. Or if the magnitude is greater than 100%, because it also be there case, let us assume that is two-phase system. Here the solid particles are less, the weight of solid particle is less, and weight of water is greater, then water content exceed by 100%, because it is related to only weight of solid, not of the all soil. If we consider the whole soil, if water content is increased, the weight of soil is also increased. But in case of solids, solids are fixed, but volume of water is increases. In that case, the weight of water is increases, and weight of water increases, that the water content is exceed by 100% is also there. There are some other terms like true specific gravity. True specific gravity. Basically, specific gravity, what is the specific gravity? It is the unit weight of soil to unit weight of water. It is the ratio between the unit weight of soil to unit weight of water. If we discuss about the mass specific gravity, then if unit weight of total soil to upon unit weight of water, we can discuss. Basically, the value of specific gravity for inorganic soil is varies from 2.6 to 2.7. For organic soil, it varies from 1.2 to 1.4. And these values also remember. Now some other terms like unit weight of soil. What is the unit weight? Firstly, we know that what is the density. What is the density? So density is the mass of solid or mass of soil, whatever, mass upon volume. That is density. What is the density? Mass upon volume. If we consider here the gravitic acceleration G, if we consider gravitic acceleration, that is called weight, because W equals to mg. You know that here m is the mass and g is the gravitic acceleration. If we consider the weight upon volume, that is called unit weight. That is called unit weight. And in a particular volume, what is the weight is present there? So that is called unit weight. So here we consider the soil in different conditions, like unit weight in condition of bulk, unit weight in condition of dry, unit weight in condition of saturated soil, unit weight in condition of submerged soil, unit weight of solids, and unit weight of water. These are the six terms are there. So here we consider all the conditions one by one. Firstly, we discuss about the bulk unit weight. We don't know in which condition soil is there. It may be solid, it may be dry, it may be saturated, it may be partially saturated. So in that existing condition, if soil in a particular time, that soil is called bulk unit weight. What is the bulk unit weight? It is the total weight. It is the total weight by total volume of solid. How much it weight? If I consider here a volume of air plus volume of weight of water, weight of air plus weight of solid upon the total volume. Here we consider total volume. So then bulk unit weight represented by gamma T or gamma V, whichever you want. You can represent it here, gamma V, and gamma T. That is suitable for you. You can represent it here. So what is the bulk unit weight? The bulk unit weight is the total weight in that particular condition upon total volume. That is called bulk unit weight. If I consider the dry unit weight of soil, in case dry unit weight, so I know that what is the weight of soil, because weight of soil is equals to weight of air, that is neglected, weight of water, that is also not there because soil is dry. Then what is the weight remaining here? So what is the weight remaining here? Only the weight of the solid. If I consider weight of solid to the total volume, that is called dry unit weight. It's simple. Directly the dry unit weight. What is the dry unit weight? It is the weight of solid to the total volume. It will be considered here. Now the saturated unit weight. I know that you also know that what is the saturated soil. What is the saturated soil? The saturated soil is there whenever all the air words is replaced by the water. Whenever all the air words is replaced by the water, that particular condition is called saturated soil. So in case of saturated soil, the total weight of soil, what is the total weight of soil? This is the weight of the water plus weight of the solid upon my total volume. So that is also the unit weight of saturated soil is called weight of water plus weight of solid upon my total volume. We can also write it here, weight of the saturated soil upon my weight of solid. We can also write it here, weight of dry soil, weight of dry soil upon volume of soil. In three conditions we consider total weight: in condition of bulk, in condition of dry, and in condition of saturated. And volume is fixed here. The volume is fixed, that is total volume. That is total volume here we considered. Now the term is now the next term is submerged unit weight. What is the submerged unit weight? If a soil is existing below the water level, below the water level, like that any a swimming pool, like that any a river bed where the river is flowing there, that means the soil is submerged by the water. In case of submarine is also there. So here we talking about the bed level of the soil. Here some water is filled over the that particular soil, that is called submerged soil. So if you want to know about the unit weight of submerged soil, it's directly you can write it here, the unit weight of saturated soil minus weight of water, or weight of water over water pressure, that you know. So what is the submerged unit weight? That is saturated weight minus unit weight of water here. So you can write it also there, weight of submerged soil upon volume of soil. In fourth and above fourth terms, we consider volume of soil. Volume of soil here. Now we are talking about the unit weight of solid. Unit weight of solid here directly mentioned कि we are talking about the solids, not the soil. What is the soil? Soil have all three components: air, water, and solids. And when we talk about the solids, that means that only solid particles we are taking care of that time. So that means the unit weight of solid, that is equal to weight of solid upon the volume of solid. Here is important to memorize, to remember that point particularly. The unit weight of solid is the weight of solid to the volume of solid of the soil. Next term is the unit weight of water. So what is the unit weight of water? The weight of water upon volume of water. Clearly mentioned that the unit weight of water, unit weight of solid, unit weight of air. That case we consider all only that volume. If we consider, if we talking about the unit weight of solid, then we consider volume of solid. If we talking about the weight of water, then we consider only the volume of water. Okay, then I think this slide is to be clear to all. Now some other important properties are also there, like that relative density. We are talking about the relative density. If a soil in a condition, a present condition or in site conditions, whenever we compress the soil, whenever we compress the soil or compact that soil, whenever we compress or compact the soil, then the void ratio will be minimum. If I compact that soil particularly, then air voids are reduced. If air void is reduced, that means void ratio is also increased. Because what is the void ratio? Void ratio is the volume of voids to volume of solid. So in case volume of voids are reduces, then the values of void ratio also reduce. That means clear, na? If we increase the voids, then void ratio also increases. So if I discuss the three conditions of a particular soil, first is natural conditions. Whenever no combustion is there, no expansion is also there. Okay, so we consider soil in a three conditions. First is natural condition. Second is uh, Emax. Emax means that losest state. Emax. Where Emax is there, if void ratio is maximum, then soil is in a loose condition. If E is minimum, what is E minimum? E minimum is the minimum void ratio. The minimum void ratio, when at which condition minimum void ratio is there? Minimum void ratio is there in condition of dense sand. So here the representation of the soil keeps if soil is loose state, soil is dense state, in which state soil is particularly present it here. If soil is in loose state, so you have to compact that soil to increasing their properties like bearing capacity, shearing strength. We are discuss about in the next lecture that properties also. And next term is relative compaction. If we talking about the relative density, if we find that soil is loose state and soil is compact state, so you have to know about the relative compaction. In a particular case, uh, relative compaction is the representation of at a gamma d to gamma d max. If a soil in a dry condition, if soil is in a dry condition, but in a loose state, and second case is soil is also in dry condition but in a dense state. That means gamma d is maximum. Whenever gamma d is maximum, whenever the all air words are to be compacted. Okay. Then you can derive that formula also. Gamma d, we know gamma d equals to g plus gamma d 1 plus e. And in case of maximum condition, the maximum condition is minimum also. Is minimum, then RCK value, that value should be 1 plus e minimum upon 1 plus e. Here is basically an important formula is there. Relative density. What is the relative density? Emax minus E minimum upon Emax minus E minimum. Here Emax is the maximum void ratio that is possible, and E is the natural condition void ratio. And Emax is also, you know that what is the maximum void ratio possible and what is the minimum void ratio that is possible. So if we consider that values in a percentage term, if I multiply with 100, that is value in percentage based. Okay, then if the relative density value is less than 50, that soil is very loose. You have to compact or improve the density of that soil. And these are the limits of the soil. If the relative density varies from 15 to 35, that condition is loose condition. If 35 to 65, that is in medium condition. Now, if 65 to 85, that is dense condition. Or if the value of relative density is greater than 85, that means the soil is very dense conditions. These are some important relationship is also there. Now the relationship between these formula to be derived here, because the point of view of the numericals in gate examination, these formula is very important. And there's a formula is play important role in numeric problems. Like that, first is what is the first volume of a solid we are discussed about. So that is volume, total volume upon 1 plus E. This relation is also we studied. Uh, Porosity is equals to void ratio upon 1 plus K void ratio. What is the volume of solid? Volume of solid is the total volume in 1 plus V. In there These formulas are looking like same, like that. Either here we consider the volume of solid, or here we consider the total work. Because we consider weight of the solid, and here we consider the weight of soil. In here we represent E, or here we consider W. W is the water content here. That formula is also very important. S E equals to Wg, where S is the degree of saturation, E is the void ratio, W is the water content, and G is the specific gravity of the solids. And this is a very important formula. You can derive it in very condition. This is a bulk formula. We know that about the what is the bulk unit weight. The bulk unit weight is the weight of soil upon weight of total volume of the soil. So here V W is the weight and V is the volume. And different conditions weight are changed, like that in dry condition, in saturated condition, and submerged conditions here. The main important formula is G plus E S upon 1 plus E gamma W. If I am talking about the dry soil, if I am talking about the dry soil, or gamma D, representation of dry soil is gamma D. So in case saturation is 0, in case of dry soil the saturation is 0. So that formula is replaced, that term is also 0. Then G upon 1 plus E into gamma W. Gamma W is the unit weight of water, E is the void ratio. If I consider in saturation condition, what is the degree of saturation? Degree of saturation 100%. All the air voids filled by the water. Then S value is 1. Then formula is replaced for saturation, G plus E upon 1 plus E. And this is the other formula of dry unit weight. 1 minus N is G R G gamma W 1 plus Wg. Here N is the percentage air content, percentage air voids. Percentage air voids, G is the specific gravity of solid, and gamma W is the unit weight of water. And W is the water content, and G is also specific gravity of the solid. Here is some also a formula, gamma bulk upon 1 plus W. W is the water content. This uh, this formula is very important, and this also, and this formula. These three formulas are very important point of view of the gate numericals. Next, the unit weight of summer soil we can also discuss. We also discussed in the last few slides. Gamma submerged equals to gamma saturated minus K unit weight of water. Here, what is the percentage air voids? Percentage air is voids equals to porosity into air content. And what is the air content? Air content is volume of air upon volume of voids. And percentage air voids equals to volume of air upon my total volume. Now we discuss about the air content. What is the air content? We also discussed degree of saturation plus air content equals to 1, because all the voids that are filled by air or water, the total quantity is always 1. Okay, then AC plus S equals to 1 in gamma saturation condition. If you know that formula G plus AC plus 1E, then you can replace S equals to 1 by, in condition of saturation, the degree of saturation means 100%, that the value of S equals to 1. All the voids are filled by the water. Okay, now we discuss, you had to take a screenshot of that slide, because that slide is very important. I replace and erase all these things that I do it here. So you have to take a screenshot of these formulas, because if you know that formulas, so you can easily solve all the numericals that are coming in your examination. For example, we are do some numeric problems also there. Any question? What is the given? A sampler has porosity is 40% and the specific gravity of solid. If a soil that have porosity that means N is 40%, N is 40%, and specific gravity 2.7. So here you find void ratio. dry density, unit weight if it is 50% in saturation condition, unit weight of soil if it is completely saturated. Here four terms you can find with the in these two quantities. Firstly, you have to note what is the given. Actually, given what is the given data? Porosity is 40%. So, what is the porosity? The porosity is volume of voids upon total volume that is given to you. That is 40%. You can write it also 0.4. That is the given data. Second is specific gravity. That is the uh, weight of solid upon my volume of solid. This data is also given. Now, what is the question asked to you? First is void ratio. Void ratio. What E? So we also know that a formula is also there in previous slide. What is the E? So that E is porosity upon 1 minus k n. This that simple formula is also given to you. Then porosity is 40%, that means 0.4. So 0.4 upon 1 minus 0.4. So you can easily find the value of void ratio. Very simple question. Sorry, that is 0.4 divided by zero point 0.6. You can write it here. You can solve it also. Now second term is dry density. Second is dry density, yeah, or dry unit weight, whatever you want to tell. So actually, dry unit weight formula is gamma d z gamma w 1 plus e 1 plus e. If unit weight of water is not given, you have to remember that the unit weight of water is 9.81 kilonewton per meter cube. That data never be given to you. You have to remember that the unit weight of water. What is the unit weight of water? That is 9.81 kilonewton per meter cube. So I take a pause for a minute. You have to solve it. After that, I will solve it one by one. All these terms: void ratio, dry density, unit weight of soil. In third question, in third part, that asks unit weight of soil if it is saturated in 50%. So here he gives saturation level is 50%. Degree of saturation is 50%. That means the voids are filled by 50% of air and 50% by water. And the next part, it is asked about the unit weight in condition of completely saturated. Completely saturated means that degree of saturation is 100%. Degree of saturation is 100%. Okay, so now we can solve it one by one. That solution is also there. What is the given data? Porosity is 14%, 40%, and G is 2.7. So firstly, the first term is void ratio. So what is the void ratio? E equals to n upon 1 minus n. Here n is 40%, that means 0.4, and 1 minus n, 1 minus k, 0.4. So you can calculate these values: 0.4 upon 0.6, that is 0.67. Okay, that value is 0.67. You can easily find the void ratio. Next term is dry density. Dry density, so we also know that formula. In last slide we also study you dry density equals to z gamma w 1 plus e. Here z is 2.7, gamma w is the unit weight of water. Gamma w is the unit weight of water. Unit weight of water, that is 9.81. Hence the value of dry unit weight, that is 2.7 into 9.1 upon 1 plus 0.67. 0.67 is the void ratio. We calculate it here, that the dry unit weight is 15.86 kilonewton per meter cube. You can easily find it, the value of that. Next, third portion is if unit weight of soil is 50% in saturation. So here you can find the unit weight. Unit weight of bulk in condition, the formula is G plus SE upon 1 plus C. Here G is the specific gravity, S is the degree of saturation, E is the void ratio, and gamma W is the unit weight of water. So write all the values in the formula and put these formula and find the value of bulk. Here G is 2.7, degree of saturation is 50%. In question that is mentioned, the degree of saturation is 50%. So you can and uh, write the value is 0.5, that means 50%, and void ratio we are calculated here, the 0.67 upon 1 plus 0.67. Here 9.81 is the unit weight of the water is also here. Then if you calculate it, the value is 17.82 kilonewton per meter cube. You can easily calculate that values. Now the last part is saturated unit weight. The what is the mean of saturated soil? The saturated mean that the degree of saturation is 100%. Here the value of S equals to 100%. 100%, that means S value is 1. Then you can write it here 2.7 plus S value is 1 and E value is 0.67 upon 1 plus 0.67, and unit weight of water is also multiplied there. Then you can solve it and find that value is 19.79 kilonewton per meter cube. These are some volumetric and weight relationship. You can find one by one. If sorry, some data is given to you, then you can find the other also with the basic definited formulas here. You have to firstly you have to memorize that what actually question want to you, what question actually want to you, and what data given to you. Then how to utilize your data or fit your data into any specific formula to find out that data he want. So firstly you have to remember all the formulas that are studied in previous slides, and after that you have to a concept or a visualization of the question. If I put that value in a question, that what the quantity to be find or found to me, or what actually question asked to me. Okay, then next question we discuss the void ratio and specific gravity of the sample. If the void ratio and specific gravity of sample of clay is 0.73 and 2.7, if the voids are 92% saturated, if the voids are 92% saturated, find the bulk density, dry density, water content. And what would be the water content for S is to 100%. There are four parts of that question. Firstly, what is the given data? Actually, given data is void ratio is 0.73. That means E equals to 0.73. That is given to you. Next, specific gravity, that means G is 2.7, that is also given to you. Next, if the voids are 92% saturated, that means saturation condition is 92%. Saturation condition is 92%, that means the value of S equals to 92% or 0.92. 0.92. Now find bulk density. Now find the bulk density. So you know that what is the formula of bulk density? Gamma equals to simple G plus SE 1 plus E into unit weight of water. Unit weight of water. Here all the data is given to you. Here all the data is given to you. What is the data you required? You required G is also there. S is also there. E is also there. Then what is the problem to calculate in bulk unit? So here you can put all the values. 2.7 plus degree of saturation is 0.92. Void ratio is also there, 0.73, and 1 plus 0.73. multiply by unit weight. Unit weight is also not given. Unit weight of water you have to know. What is the unit weight of water? In last question I also told you that is 9.81 kilonewton per meter cube. So you have to calculate these values. Next is dry density. So what's the dry density? Dry density also G gamma W 1 plus E. You can put all the values here. Next is water content. What is the water content? Water content is W. We have a formula. What is the formula? Wg equals to Se. And water content of if saturation condition is 100%, then what is the water content? So you have to solve it, and firstly I will discuss it here. What is the data given? E equals to 0.73. What is the Z? Z is 2.7 and saturation condition is 0.92. That data given to you. So firstly you calculate the bulk density. So what is the bulk density? Gamma bulk equals to G plus Se 1 plus E into gamma W. So here G is 2.7, degree of saturation is 0.92, E equals to 0.73, 1 plus 0.73 you have to calculate, and that value is 19.18 kilonewton per meter cube. That is the first part of that question. Now the second, dry density. What is the dry density? The dry density is G gamma W 1 plus E. Here G is also given, unit weight of water you know, and E is also given 1.73, so you can calculate 15.31 kPa. Now the term of water content. What is the water content at the present condition? Present condition, or if saturation level is 92%, then you have to calculate S equals to Wg, S equals to Wg. Here W equals to Se upon G, because saturation level is given, void is also given, and G is also given. Then you have to calculate water content. So here water content is 0.2487 or 24.87 percentage. Which term? A question asks that term you have to write. Okay. Now the last question is, what would be the water content as S equals to 100%? If the degree of saturation is 100%, then what is the water content? So here put the value of S equals to 1, because 100% saturation means the voids are completely filled with water. Then S value is 1. So you have to calculate the value of water content in that particular case. E by G. That is 0.73 upon 2.7. That is 27%. Okay. Any problem? You have to solve it and calculate all the values. Next question is very important question. A sample of sand above the water table is found to have a natural moisture content of 0.5 or 15%. What is you given? W equals to 15%. The water content in that soil is 15%, and the unit weight of soil and gamma bulk. If it is not mentioned dry or saturated, so you have to assume that a unit weight of soil, particularly in bulk condition. What is that? Is bulk unit weight. So what is the bulk unit weight? Bulk unit weight is 18.84 kilonewton per meter cube. Next, lab test on dried sample indicate the values of 0.5 and 0.65 in minimum and maximum void ratios. Here he gave Emax, that is 0.85, and E minimum. What is E minimum? E minimum is 0.5. These two values also given to you for dense and loose state. So you know also that if the void ratio is minimum, that means the soil is dense condition. If the void ratio is maximum, that means soil is in loose state. And G equals to 2.65, then find the value of S, then find the value of saturation, and second is relative density. So you have to think about it, in which formula we put these values and find the unit weight. take a 1 minute pause and then think over it. What values were, what formula I used in that question. If you remember all these formulas, then no specific formula is there for that, but we can manipulate these values from one formula to one formula. Like that, I know that the dry unit weight of any soil, that is bulk unit weight upon 1 plus W. You know that formula, and you also know that the dry unit weight is gamma G gamma W upon 1 plus E. Here that value is given 1 and water content is also given 15%, G also given. So here you can find the value of E. Here you find the value of E. If you find the value of E, then you can find the saturation because Wg equals to Se. Because Wg equals to Se. So here W is the water content, that is given to you 15%. G is also given to 2.67. S you have to find that, and here you can calculate word ratio is also there. So now you can find the value of S is there. Second is relative density. What is the relative density? So here you find the value of E, that is in natural state. So what is the relative density? The relative density is E max minus E upon E max minus E minimum into 100. So here you put all the values of E max, E minimum, and then you can calculate the value of relative density. Okay. So here the solution of that question. What W? W is water content, that is given to you 15%. What is gamma? Gamma is the unit weight, that is also given to you in question 18.84 kilonewton per meter cube. And what is given? E max is also given 0.85. E minimum is also given in densest state 0.5, and G is also given to the gravity, specific gravity of the solid. And what is the finding? S and relative density. So firstly we use the formula of dry unit weight. So you can calculate the dry unit weight gamma upon 1 plus W. Here gamma is the bulk unit weight. So you can put these values in that formula 18.84 upon 1 plus 0.15. Then the value is 16.38 kilonewton per meter cube. Next, you can also know that formula gamma D equals to G gamma W 1 plus E. Here you can put the value of 16.38 and you can find the value of E. If you find the value of E, then you simply find the value of degree of saturation, because S equals to Wg. S is the degree of saturation and W is the unit. W is the water content, G is the specific gravity of the solid, and E is the void ratio. So here put all the values in that formula and you can easily calculate that value of degree of saturation, that is 67.61. Now the part B, and what is the part B? Is relative density. What is the relative density? E max minus E upon E max minus E minimum. So here E max is 0.85 and E is natural water content, that is we find out. I think that here is any mistake, because that value is E equals to 0.856. So you have to put that value is here. Okay. Then calculate the value of the maximum. Okay. Next question is also there. In a Proctor compaction test, what is given to you? In a Proctor compaction test, the soil specimen of soil of the observation has bulk density is 19 kilonewton per meter cube with a moisture content of 15%. Then find the value of G. And additional moisture required to the saturated the soil specimen. Firstly, you have to understand what is the question actually want to you. In a compaction Proctor test, the observation bulk density, here the bulk density is given, that is 19 kilonewton per meter cube. Okay, and moisture content is also given in 15%. That is the same question that we done in last. And also he also want to know what is the degree of saturation. All the data is also given to you. You can put all the values here. Gamma D equals to gamma bulk upon 1 plus W equals to G gamma W 1 plus E. You can write it here. Okay, and find the value of E from here, and after that Wg equals to Se. That is the same process that we done in last question. Next, part B is very important in that case. Now, what is the question? The additional moisture required for saturated the soil specimen. If here is some saturation or some water content that is given to you here, that is given. If the water content in 15%, then you find the degree of saturation here. If the saturation is 100%, in that question it is mentioned that if the saturation is 100%, what is the additional moisture content to be determined? So here firstly you have to find the what is the requirement of the moisture that saturate the soil. After that, what is the addition? That means that content you have find here, that minus from this, so that is the additional water you have to insert that. Okay, so go for the solution. Here is the solution. Okay, so what is given to you? First is given to you bulk unit weight, that is 19 kilonewton per meter cube. And what is other thing that is given to you? That is water content or moisture content. What is moisture content and water content is the same term. So here water content is 15%. You can also write it here 0.15. And next, what is the given to you? That is specific gravity. That is 2.7 is also there. So you have to find the degree of saturation. These two formula are also dry unit weight. So you can write directly it here. Now what is the dry unit weight? Dry unit weight is the bulk unit weight upon 1 plus W. That is Z gamma W 1 plus E. Okay. So you can find the value of E from here. That is 0.603. And if you find the void ratio, then you can find the degree of saturation because S equals to Wg. So here S equals to W into Z upon E. E is the void ratio. So you can calculate here degree of saturation. The first part is completed there. That is, if water content is 15%, then degree of saturation is 67%. Okay. So in second part, that is asked if saturation is 1. If saturation is 1, that means the soil is fully saturated. That means the degree of saturation is 100%. And this formula, in that case, we are putting the value of S degree of saturation is 1 in that formula. So what is the water content W dash is required? So here W dash equals to the uh, here the required W dash value is void ratio upon Z, that is 2.23. Okay, so that is the value of water content that required to the soil fully saturated. But in question that is mentioned, what is the additional moisture content? So what is the additional moisture content? If it is 15% is also there, then you have to deduct the whole water in that case. So what is the degree of saturation is 0.223 minus 0.15%, that is 7.3% is additional water you have to insert in that particular soil to fully saturate that particular soil. Okay, so this type of questions is also many times in exams that are asked by GATE examination, and these questions are given many times 2 or 4 marks also, because they are two interrelated questions also. Their same data question are there 2 marks. So here a one question will be found at a 4 marks. Okay, and 2 marks they simply just ask about the um, degree of saturation value. These values to be calculated. Okay, so you have to practice these questions and like that or and other previous questions of GATE. So you have to easily solve. and you have to firstly memorize that all the formulas and how can you manipulate this formula in one to one and how to convert a first term to second term. That is really important to you. So firstly you have to read a question very carefully. After that you have to have mind map. Okay, what is the question actually want from you and what actually raw data in your mind. So how to your raw data is arranged in a manner that the question finding to be fine. Okay, so you have to memorize these formula again and again. You have to practice these formula of numeric problems of last previous questions like ES questions. Then you can easily calculate these values and get a very good marks in gates. Okay, so now some other questions are there. These two questions you have to solve on. Okay, so take a screenshot of that question. It's a void ratio 0.67 and specific gravity is 2.7, water content 20%. Find out the volume of water required to add it to soil is saturation. If a soil is given to you or some condition here to can find the void ratio is also there, the degree of saturation Wg equals to Se. So you can find the degree of saturation here, or then question is asked to you, so what is the water required to the full saturation condition at that particular saturation point. Okay. uh, so you have to do it your own practice and some other one and also question. Here a sample with volume of 2.5 centimeters filled with soil. The soil displays water 25 centimeter cube volume. What is the porosity and the void ratio of that soil particularly? This question is only you can solve in a minute. In a minute you can solve it if you know what is the actually question want to you. That is 1 mark question for gate only. Okay, so what is you given here? A sample of volume here is given to you, that is soil, that volume is 45 centimeter cube. The total volume is 45 centimeter cube and the sampler is filled with soil. The sampler is filled with soil. So if you consider the whole volume, your whole container volume as a soil, so that means the sampler of soil volume is 45 centimeter cube. That soil displays water of 25 centimeter cube. If you put that soil in another container, then the water displaced from that container is 25 centimeter cube. That means that soil have contains volume of solid equals to 25 centimeter square. If you got that, then question is very easy. Now you can easily find what is the porosity. If total volume is 45 centimeter cube, volume of solid is 25 centimeter cube. So what is the volume of voids? The volume of voids is 45 minus 25. You can easily calculate that is 20 centimeter cube. Now what is question want to you? That is porosity. What is the porosity? The porosity is the ratio. What is the ratio? It is the ratio of volume of voids to total volume. Here volume of voids is 20 and total volume is 45. You can easily calculate this. Now second is void ratio. What is the void ratio? Void ratio is the volume of voids to volume of the solid. So you can easily find it. What is the volume of voids? The volume of voids is remaining term is here, that is 20. And what is the volume of solid? The volume solid is 25. So you can calculate it easily. Then this value is 20 upon 45. That value is 20 upon 25. So you have to repeat and question numericals problem you can solve many times. So then these formula also memorized you, and you have to never forget that formula. If you practice more and more, then get questions it will be solved easily. Okay, so that is the first topic that we considered. What is the interrelationship between these terms, like that void ratio, porosity, unit weight of soil in dry condition, saturated condition, submerged condition, what is the specific gravity, degree of saturation. Okay. Now, the second important part of that lecture is method of determination of the water content. And many times that is asked in GATE examination, a theory question or a numeric question is also there from the determination of water content. So how to determine the water content? What is the water content? We know that in last lecture we studied that the water content W equals to weight of water on weight of solid. That is the formula of water content. If you want in percentage, so you can multiply by 100. That value is in given to you percentage. These are some methods. Some are field methods, some are laboratory methods that we are used in the finding the water content. There are some methods like that: oven dry method, pygnometer method, sand walk method, calcium carbide method, torsion balance method, and radiation method. After that, alcohol method. Okay, these are the different methods to determining the water content. So we are discussing one by one all these methods. Firstly, we discuss about the oven drying method. Oven drying method. Uh, Firstly, you have to, these two things are there. First is oven, second is desiccators. What is the desiccator? Desiccator is used to put the soil in a desiccator. After that, we put in the oven. So if you want to know the water content, you have a simple process to be followed here. What is? Firstly, you take some moist soil. Okay, you have to take the moist soil and weight it. Let us assume the weight of soil is W1. Then you have to put in a oven for a 24 hours at a temperature of 105 to 110 degrees Celsius. For 24 hours, you put these sample in a oven with the help of desiccators. After that 24 hours, you can weight the soil, and let us assume that if the weight of dry soil is W2, then first W1 is the moist weight and W2 is the dry weight. So you can simply calculate the weight of water. What is the weight of water? Weight of water is W1 minus W2 because W1 is the moist weight. After that, after evaporating the water, that weight is W2. That means the water weight is W1 minus W2. And if you find the water weight, then the dry sample W2, that is the actual water content. This is the quickest, sorry, this is the most accurate method of determining the water content. That method is also laboratory method. If any question that asked to you, what is the best, yeah, most accurate method of determining the water content, that method is oven dry method. How to calculate? Firstly, take the soil sample and weight it. If the, let us assume that weight is W1, then the sample is put in the oven for 24 hours and maintain the temperature is 105 degree to 110 degree Celsius. After 24 hours, soil is again weighted, and let us assume that weight is W2. Then you have to find the weight of water. Then weight of water, what is the weight of water? Weight of water is W1 minus KW2. Okay, and ratio with respect to the weight of solid. So what is the weight of solid? Weight is solid in dry condition. So W1 minus KW2 upon W2 into 100. So you can find the water content in that simple formulas. Okay, here we do is to are used. First is oven, second is desiccator. Now the all soils have some different properties. Like that, we discuss about the inorganic soil. What is the inorganic soil? Inorganic soil is that it don't contain any organic matters. That is soil inorganic. So for inorganic, temperature is maintained for 105 to 11 degree. In case of organic soil, the temperature to be maintained is 16 degrees Celsius, because after 16 degrees organic soil, the structural water is also in the picture, and the bond between that is also the strengthened and decayed that being. That is important question to you. If you are find the value of for inorganic soil oven dry, then temperature to be maintained at 105 to 1110 degrees Celsius. If we're talking about the organic soil, the temperature to be maintained is 16 degree. In no case the temperature is greater than 16% for organic soil. And some other thing is also there. If soil contains gypsum, if soil contains gypsum, then temperature should not be greater than 18 degrees Celsius. So you have to remember these three limits. For inorganic soil, it to be maintained 105 to 1110 degrees Celsius. For organic soil, it to be maintained by 16 degree Celsius. And for if soil contains gypsum, then its temperature to be maintained 18 degree Celsius. If you are increasing the temperature in that particular temperature, the soil has lost their structural bond, because the water in many terms in the soil, because that water is like gravity water, structural water, and adsorb water. So we we should don't want that we don't want that the structural water to be removed from the soil, because if the structural water is deficient from the water, the structural bond uh, uh, to be damaged. After that soil soil lost their strength properties. Okay, so that is the oven dry method. You have to remember that method. Second is determining the water content. Second method is picnometer method. What is the picnometer? Picnometer is simply a glass bottle of volume approximately 1000 centimeter cube, and it have a brass cap of a conical cap, and with conical cap has also a small opening to remove the entrapped air. So firstly, you can take a empty container that is called picnometer. Okay. Firstly, you take a empty container and weighted it. If let us assume that the weight of empty container, that is W1. Okay. The empty container weight is W1. Second case, you have to fill some soil. You have to fill some soil about one third of the picnometer, that is wet soil. That let's assume that weight is W2. Okay. Here the weight is W2. Now you can, in case second, you can weight the W2. In case third, you have to fill the all the voids or all the empty parts with the water in the container, all the empty part of the container by the water, and again weight it, and again weight it. If let us assume the weight is W3, that weight, and W2 contain the picnometer and wet soil. In case third, it contains picnometer, wet soil plus water. Now in fourth step, you replace all these things. You replace all these things by a distilled water. By distilled water. Now again weighted it. Now the weight is W4, that is equals to picnometer or water. These are four conditions are there. You have to arrange in that in same manner, because here is formula that give you water content, or that that method is applicable only case in, and you have to know the specific gravity of the particular soil. If you don't know the specific gravity of that particular soil, so you do not use that formula, or they do not use methods for to determining the water content. So firstly, if you have the specific gravity of what soil, then you can apply that formula. If you not given the specific gravity, so you have to firstly find the specific gravity of the soil by the same method. Okay, now that is the fourth stages. First is W1, sorry, W1. In W1 stage is empty container. Second is W2 condition. That W2 condition, there is empty container with some moist soil, that is moist soil. Okay, picnometer plus wet soil. In third condition, we have to put the empty container plus volume soil. In third condition, picnometer plus wet soil plus water. In fourth condition, the picnometer plus water. These are the four stages of the container that we have performed that test. And picnometer, first is empty container, second is empty container plus wet soil, third is picnometer plus wet soil plus water, and fourth condition picnometer plus water. All the soil is replaced by the uh, water. In that case, you have to find the water content, that is the simply formula W2 minus W1, W3 minus W4 to 1 minus 1 upon Z minus 1. That is the value of the water content is simply find in a pyknometer method. You have to memorize this. You have to a simple trick here to write it here and start from anti-clockwise direction. So you can directly remember that formula. You never be forgotten for that. W1 minus W2 stress up. You can remember W1, W2, W3, and W4. Okay. That is 1 minus U. Here is the G is used also there. So if you find the water content, you have to know about the specific gravity of the solid. If you don't know the specific gravity of the solid, firstly you have to determine the value of specific gravity. So what is the specific gravity? Specific gravity W2 minus KW1 upon W2 minus W1 minus W3 minus W1. You have to remember that formula. Here, this method is completed only in 10 to 15 minutes. You can perform that all the test and laboratory method. Next is sandbox method. Third method is determining the water content, that is sand method. This is a field method, and sandbox contain the maintenance temperature of 105 degree to 110 degree Celsius. Here we put the soil in a container and heat it, and some white papers are all inserted in the soil. When the white paper is converted into brownish, that means the soil is fully that soil is fully dried. That case, in first case, in moist soil, you have to wait at W1. Whenever the white paper is converted to brown, then you again wait it, and if the weight is W2, then you can easily find the water content. Weight of water is W1 minus KW2. Okay, upon the W2 into 100, that is water content of the particular soil. That is the water content of that soil. That method is used in a field method, but this is not a more accurate method in condition of that. Okay, so next is calcium carbide method. Next is calcium carbide method. In this method, um, we add we add calcium carbide in the soil. In this method, we add some calcium carbide in the soil. Particularly, the calcium carbide react with water. The calcium carbide reacts with water and forms a acetylene gas. This is the complete arrangement of that particular test. In that particular test, the water is react with calcium carbide. That if the quantity of water is greater than calcium carbide is generating the more acetylene gas. Then acetylene gas is more to be developed. If the acetylene gas is more to be developed, then the pressure is also be increased. If pressure is increased, then we calculate the pressure gauge to the acetylene gas is released. If the acetylene gas is released, then pressure will be more. If pressure will be more, that means the water content will be the more. Then you can calibrate the water content to the calcium carbide method. You can find with the help of calcium carbide the water content of a particular soil. Next method is torsion balance method. What is the torsion balance method? In this method is also lab method. In this method is particularly used. That method is particularly used the soil which absorb the moisture. In case of like clay, if you dried all the soil and waited that in simple cases, but the clay particles that absorb the moisture from the atmosphere very quickly, so that the correct reading should not be there. In that case, we use the torsion balance method, but the torsion balance method not practically used because it is a very costly equipment. In the normal cases and generally cases, that is not used in laboratory by torsion balance method. Next is method is radiation method. Radiation method. In this method, we provide the radiator. First is the uh, a electric capsule that also contain a steel casing, and second is the detector that is also steel cage. First, where we radiation are to be generated, and some hydrogen atoms of soil water if they are present, then they affect the radiations. And second node is detector. That detector is feel that how much isotope are deflected by the water and extracted by the water. In that cases, simply using the radiation method. The radiated as isotope that is used it here cobalt capsule. That cobalt capsule should be used. If the water is more, then hydrogen atoms of the soil is moisture is also there. It is more. That's why we can calibrate that the from the water content we find out. And these methods are to determining the water content. These 6 methods to be determined here. Last one is alcohol method. This is a simple method that is mainly used if you are determine the any water content. Firstly, you have to weight the sample, that is W1, that is the moist weight. After that, you have to put some alcohol in there, and you know that alcohol is a very uh, burning gas. So simply that is one, and after with alcohol some water to be removed from the soil, and after that you can take the weight W2, and after you can calculate W1 minus W2 upon W2. That is the water content determination methods. After that, determination of the soil water, we can also study about the determination of the unit weight. How to determine unit weight of the soil. How to determine the unit weight of soil. So you can determine some methods are there to unit weight of a soil. First is just like that core cutter method. Second is water displacement method. Third is sand replacement method. Fourth is water volume method, and last one is also radiation method. So here we discuss all the methods one by one. Firstly, we discuss about the core cutter method. Core cutter method. Simply the core cutter method is used that the soil is clay soil. What is the clay soil? What is the clay soil? Clay soil that have a particular cohesion property in that individual particles. If two particles are bound to each other, two particles that are bound to each other, that is called clay. Because the cohesion is there between two particles, so here we use that core cutter method. There are some simple instrument are here. First is core cutter, second is dolly that is put in over the core cutter, and third is rammer. So firstly you have to go on site, and after that core cutter to be stable here, and after that a dolly to be overhead that, and after that rammer you can penetrate it to in the soil. If a core cutter insert in a soil, so that soil to be connected with the core cutter to be attached with the core cutter and weighted it. The volume of the mainly core cutter is 1000 cc. cc मतलब centimeter cube, and the diameter of the core cutter is 100 mm, and the height of the core cutter is 130 mm. The dolly dimensions is also there. The diameter is also 100 meter, but the height of the dolly is 25 mm. Here is a rammer. So firstly we put the core cutter here. After that dolly is put over that, and after ramming to be done here, the soil is to be attached with the rammer, and after that we know the volume of the soil here. So firstly you determine the unit weight. What is the unit weight? The unit weight is the weight of soil upon volume of water. Here we know, what is the volume. The volume is 100 centimeter cube. Sorry, volume is 1000 centimeter cube. Here we put the soil and weight it again, and after that the total weight put here. After that you can find that. So if you find the weight of soil, so firstly you weight the W1, that is weight of empty cutter. Second, when you with the soil attached, when the soil is attached to the core cutter, so you can weight it, that is W2. If you want to weight of soil, then you can simply minus W2 minus W1, that is the weight of soil. So if you put the weight of soil is here and divide by volume, so you can find the value of unit weight of the soil. That unit weight is in bulk condition. If you want to know what is the dry unit weight of the soil particularly, so we have some methods for determining the water content. If bulk unit weight is there, so you have to put that sample in a 24 hours in a oven dry to maintain temperature 105 to 110 degrees Celsius. Then you can find the water content. If you find the water content, then simply you use this formula, this formula that are we use gamma bulk upon 1 plus W, that is dry unit weight. So now you can find with the help of the core cutter method, you can find out the all the values of unit weight and saturated condition, dry condition, bulk condition, whatever you want, whatever you want. But this core cutter method is only uses in the clay particles and clay soil, because the sand particles do not have cohesion. When you pick up the core cutter, then the soil is empty. If you use then sand, then soil, then no foundation property you have to, then the sand is empty the container, though the soil is not attached to with the container. So that method is used only for clay soil. Next method is water displacement method. Second method is water displacement method. This method is also used for clay particles. This method is also used by clay particles. Here we put some soil and then covered with a wax or paraffin wax. If you contain is a sphere or a rectangular part of the soil, and that is coated by a wax, coated by a paraffin wax or any other wax, then you can simply put the put the soil sample with wax in a water. That water displaced from that container, the water displaced from that container that is stored in a second container, a measuring flask. So measure that particular, you can measure that particular water. Here some water is displaced in the container, so you can measure that water displaced. So how much water to be displayed? That water displaced equals to the weight of that solid, because you already studied the Archimedes principle. What is the Archimedes principle? Archimedes principle is that if a body is floating in a water, that body is displaced that much water that has the equal weight of that body, particular body. Okay, so then Archimedes principle is that if the water to be displaced from the container, that is equals to the weight of the body. If the body weight is greater than the displaced water is different. So here we can calculate the total weight of wax plus solid. Here we calculate the total weight of wax plus solid. Here, firstly, the weight of the sample is W1. Second, the weight of sample plus wax is W2. Firstly, you take a sample that is W1, you weight it here. Second, the weight of sample plus wax. If you coated with the sample to with the paraffin wax, you can also weight that W2. Okay. You have to need to find out the volume. What is the volume of the sample? The volume of sample to be measured from the measuring flask. The wax coating to be done and put the water, and we can find the volume of wax plus sample. If you coating the wax to be done, then water, then find the volume of wax plus sample. Then using the G. G, what is the G? G is the specific gravity. If you know that, if the volume of wax is that, if you know that the weight of sample is that, so simply you can use formula the weight upon volume. If you using the wax, then volume of wax to be subtracted from total water space. If you know what is the wax volume, what is the wax density and volume, so you can easily subtract from the whole W2 sample. The W2 sample, you can find the weight of sample. If you find the weight of sample, then the weight of sample divided by the volume, that is unit weight of the solid. So here you can calculate the weight of you can calculate the unit weight of the soil. That is also in clay particles, because same phenomena is there, because the cohesion is not there in cohesionless soil or sands. So this method is used only for clays. Next method is sand replacement method. That method is used for that method is used for both sand and gravel. In this method you simply did a hole at a soil. If you go anywhere and that put it a hole and the soil to be baited, that is W1. Now a simple sand replacement apparatus is there, but here is a flask, a container that has the soil fill, and that is a platform to be set here. So here the soil to extract from here, the extracted weighted to be calculated easily. If you extract some soil like 2 kg 1 kg from here, then you can weight it simple W1. If in other hand we have some standard sand, in other hand we have some standard sand, and standard sand pour in that hole, standard sand to be poured in that hole. So how much sand to be poured here, how much sand to be poured in that abstracted area or sample area, that to be calculated by the, if the level is full here, if the totally cylindrical portion is filled by the standard sand, then standard sand to be filled in container, the level to be decreases from here to here to here. So h is the difference of height. What height to be reduced in container after filling to this. After filling this conical portion is also there. A conical portion and to be this portion to be calculated, and this because that is we use to standard soil. So standard soil volume is also known. If you reduce, that portion is to be reduced, that portion is empty after that filling the abstraction area. So you can calculate the volume of that soil easily. If you find that volume of that easily, because W1 is also known, because when we are extracted the soil from the ground, the extracted soil to be weighted, that is equals to W1. Then W1 to be calculated. So W1, if you have W1, then directly divided by the volume. Where you find the volume? Because the standard sand to be filled in that portion, here the volume to be emptied from here. So from here you can find the volume and you can find the weight. The weight upon volume, that is equals to unit weight. That is the simply a laboratory method to be here. So volume of soil display is equal to volume of cone plus volume of pit. Volume of soil displaced here from soil to be displayed, that is equals to volume of cone. Firstly the cone to be filled, and after that volume of pit to be filled. So here we can find the volume of pit and volume of soil sample. If you find the volume of sample, that weight is directly divided from that. Okay. Okay. Now we continue that chapter in next classes. Today classes uh, to be and here some numericals related to gate examination we discuss in next classes. Thank you very much.